Okay. When government spending increases by 1 unit, okay? So here we have this in our shorthand notation. Here we have the same thing written out in its full glory, right? A bar is the sum of the constants, these junk, okay? So when any one of these increase by 1 unit, okay, except for taxes, when government spending increases by 1, or constant investments increases by 1, or autonomous consumption spending increases by 1, right? Equilibrium GDP increases by 1 over 1 minus b, something more than 1. We know the answer. Now we want to understand why the answer is the answer. Okay? This is usually the fun thing, right? This is how modeling often works. You write down a model, you know that you're putting in reasonable stuff, you have a sense of what the answer will be, and then you find something that says, ha, I didn't expect that. Good thing I did expect this one, so I can help you out. So here's the mechanism. Government spending increased by 1 unit. Okay? So we're still in the potato economy. That means somebody wants 1 more potato. Okay? Irrespective of the income, somebody just wants 1 more potato. Okay? Are we producing enough potatoes? We were at an equilibrium. Okay? We were at an equilibrium, and then somebody says, I'm going to change my behavior. I decided that I will have 1 more potato forever from now on. Okay? Are we still at an equilibrium? No. Let's have this gentleman as the potato farmer. Okay? This is a glorious work, right? This is the only production that goes in this economy. Are you going to increase your production by 1 more potato? Yes. Does that potato have to be produced? Somebody says, I'm going to eat 1 more potato. Do we have to produce that extra potato? Yes. This is the easy part, right? So this says, look, when government spending increases by 1, GDP should increase by 1. Okay? But somehow, our advanced mathematics tell us that equilibrium GDP increases by more than 1. So something else is going on. Let's think of something else. When you increase your production by 1, what happened to total income? Total income also increased. How much? Think of this. No? We're just asking the first step question, okay? Your answer will be correct in the end, but when 1 more potato is produced, okay? What happens to total income? How much does it increase? 1. Why? Because, well, production is income, right? If you're producing 1 more potato, there is 1 more potato's worth of profits, rents, interest, and wages. Okay? Now we're getting somewhere. If our income is increased by 1, okay, is the total income now higher by 1? Yes. Does our consumption spending stay the same? No. The answer is there. So the question is, well, what happened to disposable income? Did it also increase, or did it stay the same? Look there. It increases. By how much? So y increases by 1. What happens to taxes? Very good. We made our life easier at the beginning, right? We said taxes are independent of income. Taxes are constant. So taxes didn't change, but income increased by 1. What happened to disposable income? Disposable income increased by 1. If disposable income increases by 1, what happens to consumption? Let's ask this young man. If your disposable income increases, don't look at me, look there. Consumption is A plus B disposable income. If disposable income increases by 1, what happens to consumption? It increases. Increases is the right part. More than 1 is the weird part. How do you get that more than 1 when you look at that equation? Even in terms of non-economics, just math. Disposable income increases by 1, consumption increases by? Well, you know exactly what the answer is. It increases by B. Okay? Right? Yes. Very good. Less than 1. That's the only reason we get to an equilibrium in the end. Okay? So look, government spending increased by 1. We had to produce 1 more potato. Then consumption spending increased by B. Do we have that B units of potatoes somewhere? Or do we have to produce it? What do you think? Government said, I want 1 more potato to eat. Okay? That's all we do in this economy. We eat potatoes. When the government says, I'm going to eat the potato producer produced that. So GDP increased by 1. When GDP increased by 1, we said, ooh, we have more income now. So we could eat more potatoes as consumption. Okay? So we said, we want to eat B units more potatoes. Where are those potatoes going to come from? Well, they're not going to come from anywhere if this guy doesn't produce them, right? So is he going to increase his are you going to increase your production again? Yes. Okay, now we're done. He already told me that he's going to increase his production once again, B more units, right? What is the total increase in production now? 1 plus B. Okay, cool. But do we stop there? Government spending increased by 1. Income increased by 1. Disposable income increased by 1. Consumption increased by B. Therefore, production increased by a further B. When production increases by B, what happens to income? It increases. By how much? B. Very good. You're smart people. Income increases by B. Taxes are constant. Disposable income increases by B. If disposable income increases by B, what happens to your consumption? This is where advanced mathematics kicks in. B squared, very good. Okay? So now you see that this is this endless process, right? I'm looking at the following. Government spending up by 1, okay? Says GDP up by 1. Thus, this is in this model, okay? If I had taxes tied to income, right, this next step would not be correct. In this model it is. Disposable income up by 1. Thus, consumption up by B. Thus, GDP up by B. Thus, disposable income up by B. Thus, consumption, let's see, what happened by 1, consumption, blah, blah, blah, blah, disposable income by B. Consumption is up by B squared. Okay? If you've seen this B squared step, then you're done. Yes, sir? Yep, you can do this in English.
There is 2 disposable income.
Yes, and there's also 2 GDP and 2 consumption, right? Government spending increases by 1, GDP increases by 1, disposable income increases by 1. This was the first step. Therefore, consumption increases by B. GDP has to increase by a further B. Disposable income has to increase by a further B. When disposable income increases by B, consumption increases by B squared. This is going to go on. Can we add up the increases here that we see in GDP? Right? We see that we have this 1, and then we have the B, and then we have the B squared, right? Is there going to be a B cubed here? I mean, what is special about B and not there about B squared, right? When consumption increases by B squared, will GDP increase by B squared? I, the consumer, am saying, I want B squared more bits of potatoes. Will this be produced? Yes. If it's produced, is GDP going to go up by B squared? Is disposable income going to go up by B squared? Yes? Very good. If disposable income increases by B squared, what happens to consumption? Increases by B cubed, okay? So this is going to go on like this. Plus B cubed, plus B to 4, plus blah, blah, blah, right? Since you're extremely mathematically inclined, you could write this as the summation from 0 to infinity to, right, B to I. Okay? What does this sum to? Okay? Ha! Lovely. In my beautiful sliding down writing, you can see here that the reasoning is clear if you think like the economist. Okay? Your mathematics will tell you the end result. It's not going to give you the economist intuition. Right? But when you think about it, what is going on is the following. Government spending increasing will cause an increase in GDP. Increased GDP, okay, because of the way we model things, and we believe in this model. Okay. Now, excuse me. The deal is this. Our economics reasoning tells us that because GDP is income, okay, because every bit of production turns into income for someone, once you begin to increase production, you're making people have more income. When they have more income, they want to consume more, which means you will get to produce more. Okay? So that's this process. This process is called the multiplier process. Okay? And it's for this kind of thing that we study economics, right? I mean, if you've gotten this tiny bit of perverted pleasure out of understanding this, okay, you're cut out of the right economists. This is a translation from Turkish, but you will understand it. You're cut from the right economist cloth. İktisatçı kumaşından geliyorsunuz. Why is this? Look, there's a lot of things to be learned from this, right? It says, if the government wants to make the GDP increase by, say, 100 million liras, okay? Should the government increase spending by 100 million liras? Really easy question. I want equivalent GDP to increase by 100 million liras. Must I spend 100 million liras as the government? Why not? Sure. If I spent 100 million liras, right, that means this is going up by 100 million liras. What is going to happen to equivalent GDP? Thank you. Okay? So it says small increases in government spending have large impacts on equilibrium GDP. Neat, isn't it? The question then becomes things like the following. First of all, man, we wrote the stupidest model we could think of, right? There aren't even any prices. So would this keep on being correct if I had a model where producers aren't willing to produce infinite quantities? You know, what if this guy, the potato farmer, said, sure, I would produce one more unit, but I would also charge you more for it. The price would increase. What would happen then? That's a good question. We should think about this next week. Okay? But we could also ask other questions. Things like, should we think that this multiplier would be larger in richer countries or in poorer countries? Okay? If we know nothing else.
Poorer countries, since the marginal propensity of consumption would be higher.
This is exactly the answer. Okay? Look, when is the multiplier high? In this model, again, in this model, when B is large, right? When B is close to 1, this thing blows up. Why? Because your advanced mathematics tells you that when B is close to 1, this thing is close to 0. When you divide 1 by something close to 0, you get something like large. Okay? When B is close to 0, then this thing is close to 1. Okay? So you're saying, look, in countries where the marginal propensity of consumption is low, okay, where people save a lot, government spending doesn't have the same kick as in countries where marginal propensity to consume is high, where people consume a lot of their extra income. Okay? Here's the question. Let's think of a rich country. Everybody already has, say, $50,000 of yearly income. And then they get one more. Would they spend it or save it? Okay? Then think of a poor country where people on average have $1,000 and then get one more. Would they spend it or save it? Okay? Now we know this empirically as well. This is in the data. Poorer people spend more of their marginal income. Why is that? Well, because they are not able to cover all of their necessities, right? If you're saying, you know, I can barely feed myself, right? If you get 1 more lira, you consume it, right? You feed yourself better. If you're saying, you know, I have a great life anyway, if you get 1 more lira, you don't even notice you get 1 more lira, okay? So then this gives you some very good economics advice. If all government spending aren't the same, if you can do targeted government spending, if you could do spending in a way that said the disposable income will go to poor people versus rich people, okay? Who do you want to target? Not in terms of economic justice, that's different, okay? In terms of justice, I hope we all want to target the poorer people, okay? But say we only are interested in increasing the GDP. In that case, do we want the disposable income of the poor people to increase or the rich people to increase? Who is going to spend more? Do we want people to spend more? Okay, there was this great point here that said, well, investment, okay? You have to be model consistent. What happens to investment in this model? Nothing, okay? We're going to get all of the kick from consumption spending, okay? So this model tells you that you have to target the poor people because if spending is going to increase, it's going to increase by consumption. So you want the people who will consume more to have more income, okay? That's going to be the poorer people. Very good. This was kind of fun, wasn't it? Now, if you understand this, the rest of the semester is easy, okay? Everything builds on this bit. So, take a good look, right? Equations, graphs, words, I mean, serious science going on here, okay? You must be very comfortable with this multiplier process, all right? For 2 reasons. One, you know, it's one of the more important things that's going on in the economy. But 2, if you understand this, if you can convince yourself that, yeah, I understand it at a level that I could explain it to my grandmother, okay? And this is one of those things that you could explain to your grandmother, right? Then you really understand what we've done so far. Okay. Now, here's a beautiful question. The government can stimulate the economy by doing 2 things that have the same impact on the budget deficit. It could increase government spending by 1 unit, or it could decrease taxes by 1 unit, right? These would both make the budget deficit increase by 1. Do we have a preference? Should the government increase government spending or decrease taxes? So this is the bullshitter's answer, right? Decrease taxes. There's a model. There's a reason why we wrote this model. Okay? Will they have the same impact? Really? Government spending up by 1, equivalent GDP increases by 1 over 1 minus b. Taxes down by 1, what happens here? There's this b floating here, right? When taxes decrease by 1, okay, government spending goes up because there's a minus sign. Taxes are down, but it goes up by b over 1 minus b. Which one is larger? 1 over 1 minus b or b over 1 minus b? How do we know? Because b is less than 1. Okay? So clearly, increasing government spending has a larger multiplier than decreasing taxes by the same amount. Now comes the good question. Why? Think of the process. Of course, multiplier. Yes. So in this model, the multiplier is the answer to everything. Okay? But it's important to see why. Look, what I'm telling you is that the government spending multiplier is 1 over 1 minus b. The tax multiplier is b over 1 minus b. Why are these different? Why is the tax multiplier smaller than the government spending multiplier? Yeah, b is less than 1, but what is the story? The question is, why do you end up with b over 1 minus b in 1? I can see the math, and I'm sure you can do, right? But what is the economics?
The taxes going are income, and when taxes is decreases, are equal to?
Yes. This could be better said, but this is the main idea. The point is this. Think of this process, okay? How does this begin? Government spending increases by 1. That means government wants 1 more potato, right? So 1 more potato has to be produced. Now, the alternative is taxes decrease. Taxes are down by 1, okay? What happened to your disposable income? It increased by 1. What happened to your consumption? It increased by B, not 1. You start from B and then go on, okay? So this is lovely, right? This kind of argument takes place a lot in the US, right? In Turkey, we don't have usually economic policy arguments along these lines. But there are people who actually say, you know, we're Republicans, we want smaller government. If you want to stimulate the economy, do this by cutting the taxes, okay? The Democrats will tell, no, what we want to do is stimulate the economy, and we're going to do this by increasing government spending. Are they all the same? Apparently not, okay? And this ECON102 information, knowledge, comes extremely handy in trying to choose between policy alternatives, okay? When you increase government spending, you know that expenditure is increased. You are the one doing the spending. As the government, you know that spending has increased, okay? When you decrease taxes, it's up to the people to choose whether they want to increase their spending or just to save what you've given them in terms of lower taxes. Very good. So out of this dinky little model, we got a lot of mileage, right? Very nice. Now, the next step is going to be the following. We did the model with no prices. The question now is, can we do prices, but elastic supply? So this means something to 101 guys, okay? For the rest, it means there will be prices, but producers will be happy to produce as much as you want at any price, okay? They will never want to change prices. Can we write a model of this sort? Sure, we're smart people. The difficulty is the following. When we have these expenditure, income, government spending, blah, blah, are these real variables or nominal variables? Very easy question. They have to be real. There are no prices. We can't even define what nominal is in a world with no prices, okay? So these are real variables. Now, how do you mix real variables with prices? Okay? This is once again, remember, this is once again one of those questions where understanding why the question is a question is harder than understanding what the answer is. Okay? So the question here is going to be, let me erase this and write the alternative model. So now we're going to have a world where there are actually prices, okay? So we could ask, what happens if prices change? But we're not going to ask, how do the prices change? Okay? So the prices will be these externally given, you know, God says price will be 5 today. The next morning we'll wake up, we all know that price will be 7. Okay? Because we have to do this to get to the point where we could endogenously, inside the model, pin down the prices. That's how our first assumption is the same, okay? Closed economy. Investment is constant. Government spending is constant, okay? So the mileage is going to come from consumption. So now I'm going to say, let's have consumption is A plus, let's have taxes constant too, okay? So the model is identical, except for, let's put in prices here. Should consumption be a increasing function of prices or a decreasing function of prices? Do I want consumption to increase when prices increase or decrease when prices increase? So the problem here is The obvious answer to this question, if you think hard, is it should be irrelevant. Because here I have real disposable income. Here I have real consumption. Who cares about what prices are? 20 potatoes of disposable income turn into 15 potatoes of consumption. Does this depend on the price of potatoes? You always have 20 potatoes. And there's only potatoes in this economy. Right? This is where understanding the question is more difficult than understanding the answer. If I just told you that I'm going to model it this way, you would just nod your heads and say, sure, yes. When prices increase, consumption spending decreases. Okay? It's not that easy. Indeed, we're going to model it this way, but not for the reason you think. Okay? First, I want you to understand the following. If consumption is out of disposable income, okay, and I'm telling you that, your yearly income is 20 potatoes, okay, how many of these would you eat, and how many of them would you spend?
10 of my eat.
Okay. 10 of them she eats, 10 of them she saves. She didn't even ask me what is the price of potato. Okay? That's what makes me say, look, even when I think of prices, this C should be 0 because it's enough for me to tell her you have 20 potatoes. That's her disposable income, right? She knows what consumption is. The price is irrelevant. Okay? Why is this happening? This is macroeconomics. These are aggregates. Okay? So here I have the price of everything, the real quantity of everything. Here I have the consumption of everything. Does the price matter? It doesn't. Okay? So, but it should. I mean, you also must have this feeling that I'm tricking you, right? Because obviously the price must matter for something. And what is going on here? Okay? So again, the model consistent answer here is that you don't only consume out of your income. Okay? You consume out of your wealth as well. What is the difference? Income is flow, your yearly income. Wealth is stock, how much you have saved. Okay? Do you have savings? You have a bank account? It's time that you have a bank account. Does anyone have a bank account other than me? Very good. Do you have something in the bank account? What do you have? You don't have to tell me a number. 500. Okay. So he has 500 what? Potatoes in the bank account?
Potatoes.
No. Seriously.
Yes.
Do you have potatoes in your bank account?
Yes.
Liras. I thought you were saying yes. He has 500 liras in the bank account. Okay? When the prices increase, what happens to his real wealth? When the potato price is 1, okay? How many potatoes do you get to buy with the money you have in your bank account? That's 500, right? Good math. Now a harder question. Say the price is double and the potato price is now 2. How many potatoes can you buy?
250.
Very good. You'll go far in life. 250 potatoes is now all he can afford with his savings, with his wealth. Would this affect your consumption behavior? You used to be able to afford 500 potatoes with what you had said earlier. Now you can only afford 250. Does your consumption change? Yes. And that's why. Okay? If we were only spending out of our income, then what we would have is, okay, real variables, prices increase, disposable income increases, right? So nominal quantities change with prices, but real quantities don't, okay? But now what we're saying is, but wealth is kept in terms of money, not in terms of potatoes. Wealth is a nominal quantity. When prices increase, real wealth decreases. This is called the wealth effect, okay? And this is going to be the answer in this model of why is aggregate demand downward sloping? Why does aggregate demand, this is in your homework, okay? So you're getting a benefit out of coming to class, right? One of your homework questions say, why is aggregate demand downward sloping? And it says in parentheses, the answer isn't when prices increase, we demand less. Okay? Now you understand why that isn't the answer. This is the answer in that world. Okay? So now we have this as our consumption function. Okay? We're saying, rather than having consumption depending only on disposable income, I'm going to have it depend on disposable income and prices. Can I solve this model as well? Do I know how to go through the motions? Can I find what aggregate expenditure is? Yes. Can I find the equilibrium point of aggregate expenditure? So we're going to see it's going to be slightly trickier, but yes, I can do this. Why not? So, well, let's do it. All right, let's add these things up. So we're going to have aggregate expenditure equals A plus B y minus BT bar minus CP plus I bar plus G bar. Right? Do you agree? The lady in this striped thing, yeah, you. Do you agree? Not you, the person. Do you agree?
I don't know.
You don't know. It's sad. What is it that you don't know? Nothing? You live in this big void? Do you agree that I can write consumption like this? Terror, stress. Look at the camera. It is important that you convince yourself that this is the way to go, okay? So on Monday, I'll be picking on you, all right? Come prepared. And you'll remind me to pick on her. Do you agree?
Yes.
See, this is the easy answer, yes. Look, what I want you to see is, what I did here is exactly the same thing that I did earlier, right? I wrote down components of aggregate expenditure. I added them up, right? Good. So now what I can do is, I can again put all of the constants together, okay? The question here is, what am I going to do with this P? Is this a constant? No. But I don't know what it is, okay? So things are going to get uglier, because this time I'm going to have aggregate expenditure equals, once again, bunch of constants, right? Plus BY minus CP. Now I have one equation in 3 unknowns. Can I plot this? Can I draw the graph of this equation? Well, if I'm able to draw in 3 dimensions, I could, but I'm not quite that good. Can I do this? Here's Y, here's aggregate expenditure, I want to draw that. Can I do that? How do you draw 3 equations, 3 variables in a 2-dimensional plane? Can't do that, okay? But I'm a lazy but clever guy, so rather than drawing in 3 dimensions, I could do this. I can pick a price level. I could say, let's do this for P0 equals 1. Let me pick a particular price. If price is 1, okay, can I draw this now? Sure, because now I'm plugging a number here. What will this look like? It's going to be something like this, okay? Now I'm going to note here, this is for P0, right? Can I also do this for, let me also find my equilibrium GDP here. Can I also do this for, I don't know, P1 equals 5, some other price? I'm going to pick another price. I'm going to say, what if price was 5 rather than 1? Can I also draw that? What's going to happen? Shift up or shift down? Shift down, right? Why is that? Because, look, prices are higher. This guy's bank account now affords him less potatoes. He's going to consume less at any income level. Therefore, expenditure is lower. Okay? So I can do this. This is P1, right? What happened to equilibrium GDP? It was here, now it's here. Can I do this for any price level? Sure. I mean, if I can do it for one, I can do it for all. Okay? So can I do this for P2 equals, I don't know, 0.3? Would this work? Sure. Why? Any number will, well, prices better be positive. Other than that, any number will work. Okay? So that's going to be this. This is P2. Okay? Now, could I do this? It seems like I know what equilibrium GDP should be for every price level, right? I, as the economist, can now say, tell me what the price level is, I'll tell you what equilibrium GDP is. Can I plot this relationship between equilibrium GDP and prices? Slightly deeper thinking, but the answer is sure I can. I could do this. Let me have Y here and P here, okay? So I have, this is P0, right? P2 is lower, so this is P2. P1 is higher, this is P1, okay? And I can bring this down from here. So for P0, I have here, right? For P2, I have here. For P1, I have here. There's a name for this thing. Aggregate demand. Okay? This is what aggregate demand is for the macroeconomist. It tells you what equilibrium would be, okay? What equilibrium demand and equilibrium production is for each given price. What is my problem? Do I know whether I will be at this point or this point or this point or any other point on this curve? I still have two equations. Wrong. One equation, one line, and two unknowns. I could be here. I could also be here. I could also be here. What is the price? Right? If somebody tells me this is the price, then I'm done. Okay? But I can't know the price myself. What do I need for this? It should be really easy when somebody says, I have aggregate demand, I need something else. What do I need? Aggregate supply. Okay? That's going to be next week. But so currently what we're doing is we're saying, you pick the price, okay? For any price, there is an aggregate supply curve that looks something like this, okay? It's flat. These guys are happy to produce as much as you want. Okay? Now, do you understand the magic that went on here? It takes some getting used to, okay? You know, do this at home once. Then you will understand. There's nothing difficult, there's nothing interesting. Here's what we did. Can we find the equation for this line? Yes. Why? Because, well, I already have one equation in three unknowns. But I have a second equation that says aggregate expenditure equals Y at equilibrium, right? The 45-degree line. Can I put the two together? Yeah. So then we'll have Y equals A bar plus by minus cp. Thus, I'm going to have y equals 1 over 1 minus b a bar minus c over 1 minus b p. What is this? This is the equation of this line, right? I'll give you like a minute to think about this, okay? Then I'll begin asking questions. Should I ask you this time? And then we'll both be fired if you can't answer. All right. So let's begin to talk about what's going on here. Okay. Once again, we have to be able to do this three ways. Understand the equation, understand the graph, and understand the economics of what is going on. Okay? If you understood the earlier, simpler model, the economics is the easier, right? Because all this is saying is, I think because of the wealth effect, consumption decreases as prices increase. Okay? What is going to happen to equilibrium GDP as prices increase? If consumption decreases, what will happen to equilibrium GDP? It will decrease. There you have it. Okay? That's the economics. The graph says I can find the equilibrium point of expenditure and income for different price levels. If I can do this, then I should be able to plot the equilibrium income versus the price level that I chose for that income level, right? That's this. Okay? The equation says, well, you know how to derive the equation of aggregate expenditure, which is this. You know that at equilibrium, this should hold. You have a problem here because you have 3 variables and 2 equations. You can't get an equilibrium point, but you can reduce this to 1 equation in 2 unknowns, which is this. That equation says GDP increases as expenditure, autonomous spending increases, but it decreases as prices increase. That's this. Okay? Now let's ask the question that is a graphing nightmare, but very easy with the equation. Okay? Let's say we did this. Then I said, what happens if government spending increases by 1 unit? What happens? Okay, so what is increasing? I hear this increase mumble, but what is increasing? Okay, GDP increases, but here, does this line stay the same? Does it shift? Really? This line is the representation of one of these, right? I pick the price and I plot the line. Does the line stay the same if government spending and therefore A bar increases by 1? I'm asking this lady now because she was arguing that it would stay the same.
It was to that.
Up, down, help me more. Okay, it will go up. Why? Because look, it says at any income level, and given the price at any income level, the government wants to spend more. Okay, this line will shift up by 1. What about this line? Will this stay the same? If one of them shifts, all of them shift, right? Right? Very good. Then what happens to this line? This one shifts too, right? This way, that way, that way. Let's draw this somewhere else. This is P, this is Y, this is aggregate demand, and this shifts here. What is this distance? The answer is here. Autonomous spending increases by 1. At every price level, what happens to aggregate demand? How much does that increase? Thank you. Right? This distance is the multiplier. So now we understand that when the multiplier is large, a given government spending increases total demand more. Okay? Let's talk about this again. In the model with no prices, we were talking about equilibrium GDP, right? Government spending increases, what happens to equilibrium GDP? Now, we can no longer know the equilibrium GDP because we don't know the prices. But we can know what happens to aggregate demand, okay? So the question is, when government spending increases, okay, does production increase? Yes. Do disposable income increase? Yes. Does consumption increase? Yes. All of these are components of aggregate demand. Right? We want to consume more. The government wants to use more. Okay? We're not asking, are the producers willing to produce more at this price? We're assuming that, yes, the price was 80 here. This is your aggregate supply. It's flat. Okay? Equilibrium is governed. If you know the price doesn't change. Okay? Under that assumption, all that matters is what happens to aggregate demand. When does aggregate demand increase more? When the multiplier is large or when the multiplier is small? What do you think? Under which model, under which parameters is government spending more effective in controlling aggregate demand? When the multiplier is large or when the multiplier is small? Large. Why is that? It's exactly the same reasoning as we had before. Okay? When 1 unit of government spending increases your production by 1 unit, okay, does it also further increase your consumption? Yes, this was the whole multiplier story, right? When does it increase it more? When the multiplier is large or when the multiplier is small? Okay, that's what the multiplier is. Okay, so the multiplier here measures how much your aggregate demand curve shifts for a given increase in autonomous spending. Okay. Now we covered a lot today, right? This was a serious economics lecture, right? Think about this. Come prepared, because next week we're going to say, well, let's think about aggregate supply. Have fun. See you on Monday.